go live? Are we going live? Awesome.
Yeah.
So hopefully you guys can hear that. You guys, a few more. Two people on the stream. Two people. Two people on the stream. Crack the code. So, welcome everyone who to today's virtual lunch and learn. Crack the code to higher RAG relevancy, the AIMon and ApertureData solution. I'm going to give everyone a few minutes to join and to grab a cup of coffee, settle in, and get comfortable. And then we will begin our program shortly. Wait, everybody's done. Screen, do.
Deniece, I think you're on mute. I see that you're talking, but
Oh,
yeah.
sorry. Thank you. Um, so once again, thanks for joining our lunch and learn. I'm giving everyone a few minutes to settle in. And as everyone is joining, I would love to get to know who is on the other side a little bit more. So my question for the session is, what hidden talents do you have? Do we have maybe a budding Picasso in our midst, perhaps a DJ on the side? Or maybe someone who makes a mean lasagna. So go ahead and pop your answer in the chat. I'm going to go ahead and pop the question um, um, in the chat as well. Um, so maybe I will go first. One of my hidden talents is I love to dance. So that's mine. So if anybody else wants to chime in regarding their hidden talent.
I can go as well. I've recently learned how to make a good cup of tea, so pretty
Ah,
happy about that.
so that's pretty awesome. Good tea. Good tea works.
And I can make a very nice omelet.
Ah, okay. So we have some great cooks in our midst, a tea maker and a omelet maker. So if the engineering thing doesn't work out, there's there's a
We know where
chance
to
for
go.
exactly there's a second chance. All right. So I'm going to go ahead and get started. I want to welcome everyone to our Lunch and Learn series. I'm excited that you've chosen to join us today for a really exciting and interesting topic, and that is crack the code to higher RAG relevancy, the AIMon and Aperture Data Solution. It seems like a couple of people have joined in about their hidden talent. One person is a bread maker, so it seems like we're having the makings of a cafe: tea, bread, omelette, and then of course someone else loves cocktails. So So when you're all done with the breakfast, then maybe we can go right into brunch or the after drink, the after drink meal. So that's pretty awesome. The makings of a restaurant. Um, so today's session, we are joined by Preetam Joshi and Gautam Saluja. Before we get started, my name is Deniece Moxy, and I'm the Director of Product Marketing at ApertureData, and I'll be your host for today's session. Before we get started, there are a couple of housekeeping details. The recordings of the Lunch and Learn will be available on demand after the session. Please post your questions in the chat window, and we'll get try to get to them. If I do not get to them during the session, I'll follow up via email. Links to resources will be provided in follow up emails, so you'll be able to see all the collab notebooks and also how to sign up for both AIMon and ApertureDB to try some of these ideas on your own. And then finally, enjoy and have fun. For today's Lunch and Learn, the agenda is pretty straightforward. First, we'll have speaker introductions. Both Preetam and Gautam will go ahead and introduce themselves. Next, they will take a few minutes to talk about their perspective technology, AIMon and ApertureDB. And then finally, we'll get into the fun and the deep dive. And that is Preetam will show us um, how to build highly relevant RAG with AIMon and ApertureDB. And he'll be showcasing a collab notebook that you will have access to at the end of the session. So you can begin building your own, building and playing with your own applications. So to get started, I'm going to pass it over to Preetam, who and Gautam, who can begin with their introductions.
Wonderful. I can go first, and Gautam, then I'll hand it over to you. So I'm Preetam, one of the co-founders of AIMon. My background is in the intersection of applied machine learning, distributed systems. Been at AIMon for about a year and a half. Prior to that, I was part of the machine learning platform team at Netflix, and then been working on applied machine learning problems in big and small companies in the Bay Area. Gautam, you want to go next?
Yeah, my name's Gautam, and I'm a software engineer at ApertureData. My area of focus tends to be the SDK, which gets shipped to the users who want to use ApertureDB, and I try to make it very intuitive and e- straightforward to get the data in and out of ApertureDB.
Awesome. Thank you both for that wonderful introduction. Now, the next up is perhaps Preetam, you can begin by sharing an overview of AIMon, the technology, and then
Mhm.
Gautam will have you do the same for Aperture Data and ApertureDB.
Yeah, absolutely. I can actually present my screen and we'll
Oh,
walk
okay.
through a quick slide which will showcase this thing. So let me just present. All right. Hope you all can see my screen.
Yes.
Right. Okay. Um, okay. So AMON. So we are an LLM reliability platform, and I'll get into what that exactly means. Essentially, we help build more relevant LLM applications. And the way we do that is by helping you interface with your current applications using our host of SDKs. You are able to choose between Python or TypeScript. I know TypeScript is very popular among folks building in this area. And then you can send in your data that your LLM application generates, and this data can include all sorts of things, things like the LLM response, the kind of data that you retrieved from your vector databases, or the context data that you're using for an LLM to generate a response. All of those things can be sent to AIMon via this SDK using very little code, maybe a few lines of code. And I'll show you in a little bit how that works. And then AIMon runs its proprietary set of checker models, which check for things like hallucinations, instruction adherence. And what instruction adherence means is whether your LLM followed all of the instructions that you shared in your prompt or not, right? And then also a bunch of different safety features and relevance features. And then we allow you to do a few things. You can, based on the feedback from these checker models, you're able to implement guardrailing, which will essentially help you, not have hallucinated responses at the very end to your customers. We allow you to get insights if you don't want to do an inline guardrailing. And those insights will be either on the output of your LLMs or on various different data patterns that you have in your application or on your RAG, right? And then finally, you can take that and feed it back into your application to improve all of the different components, specifically on your RAG or your LLM. Yeah, so that's a very quick overview of what AIMon does. And I will get into more details about it in our talk. So I'll hand it off to Gautam to chat about Aperture.
So, Aperture Data has a product, ApertureDB, which is a database built to house all kind of data, not just the structured data as we like very familiar with other databases. Uh, Unstructured data could be images, videos, PDFs, what you have. And Aperture DB actually treats it so that it is understood semantically as to the concepts in the images or the parts and the bits that constitute a video. So it's not housed in the DB like a typical database would think of a blob, but more like uh, uh, an object that has certain properties that are correlated to what images and videos and such other things represent. So the intent for building such a kind of DB uh, is that it unifies the access to the DB to the data in a way, in an API which is very streamlined and consistent, and it doesn't let. I mean, it enables the application developers to write complex queries close to the source of data rather than having to aggregate a query from one system and then index into some other kind of storage system, and then make a glue sort of a thing. Uh, it's also has some kind of target audience which who dabble a lot with machine learning, with visual, and with focus on visual and media elements at the moment, but it's generalizable to accommodate a lot of other formats as well. That's a bit of brief introduction of Aperture DB.
Wonderful.
Thank you, Preetam and Gautam, for the great introductions as well as information, high level information about sort of the technology of both AIMon and ApertureDB. So now we're going to get to the fun part of our lunch and learn, and that is Preetam will be doing a deep dive and illustrating how to achieve higher RAG relevancy by combining AIMon and Aperture DB.
Wonderful. Thanks, Deniece. This is exciting. So, all right. So let me switch to my screen here. Um, then I'm just going to do this. There we go. I hope you all can see my screen and whatnot. Um, so for the purposes of this presentation, I'll actually be focusing on this notebook entirely. There is going to be maybe one other slide which I will switch to just share some additional context, but primarily it will be we'll be spending most of our time here, right? And yeah, as we go through this notebook, please feel free to drop in any questions, as Deniece mentioned, would or interrupt me. I would love to make this interactive. So we'll be going over this notebook, which demonstrates how to improve the relevance of your generative AI application using AIMon and ApertureData. Right. So for the purposes of this talk, we'll be using a data set which is, in my opinion, very representative of the real world. And this is the meeting bank dataset. So essentially, we'll build a chatbot through the end of this exercise, where you can essentially ask questions over this meeting bank dataset. Right. And just to give you an overview of this meeting bank dataset, it's essentially a benchmark dataset that was created from city councils of 6 major cities to supplement existing datasets, and it contains about 1,366 meetings with over 3,579 hours of videos as well as transcripts. In Yeah, so and on average, this is also important. On average, a city council meeting is about 2.6 hours long, and it contains transcripts over 28,000 tokens, right? Um, so this is important to keep in mind. I also want to stress that we'll be focusing entirely on text here, not necessarily on video, on the video of the recording. So essentially, we'll be looking at the transcripts that were generated from these set of meetings, right? So what you will learn is you will learn how to define and measure relevance of your LLM application using AIMon. And then you'll also learn how to build an LLM application that answers a user's query related to the meeting bank dataset, leveraging the amazing APIs that ApertureDB provides, right? Um, and we'll be getting into some more details of that shortly. So the tech stack is pretty straightforward. From a vector database point of view, we'll be using ApertureDB, which is a specialized database for multimodal data. And Gautam went over some of its capabilities recently. So you should be aware of that. But there is some resources linked directly in this notebook that we will share, of course, after the end of this presentation that you can refer to. And those resources include this notebook as well, right? Yeah, in terms of LLM framework, we will actually leverage an LLM framework called LlamaIndex. For those of you who are not familiar with it, it's just a framework that helps manage, data, helps connect the different LLM models, and really build robust, generative AI applications. And we'll be also leveraging Aperture Data's LlamaIndex plugin for this, along with, how, and I'll show you how AIMon can be used with LlamaIndex for these cases, right? Yeah, and then finally, for the LLM quality evaluations, AIMon offers a bunch of other detectors. So we'll basically use that to showcase how it all works and comes together, right? So we'll be talking about that in a little bit. So the first thing that you need to do is that these are all prerequisites, just some housekeeping stuff. You need to install LlamaIndex. There's also a few libraries over here that you need to install. Obviously, the AIMon library, we have a PyPy package that we publish. There are a bunch of utility functions added in this notebook, which you don't necessarily need to pay attention to. But just for a quick overview, we have some functions related to OpenAI, to talking to the LLM, some functions that help generate embeddings. And then, yeah, this piece essentially installs ApertureDB's LlamaIndex plugin, right? And then all of these pieces here are to set up ApertureDB, which I have already done as part of this particular meeting, right? So, so these things essentially help you, like you can use the collab secrets here. So you can see that there are this secrets tab. It's a good way to store secrets and share it with your notebook. So some of these things are already stored in that. And then finally we have this connector which connects to the ApertureDB instance. And this is a remote instance on the cloud, on the ApertureDB cloud that we are using. And you can see that once you connect to it, it gives you some details on the descriptor set, and what are the different forms of descriptors and whatnot, right? So I'll go ahead and uh, compress that. So, okay, so the first thing that we will do, again, we will go through this notebook. So, um, praying to the demo gods that everything works well here, but we'll ensure that this notebook is we'll execute this notebook step by step to see how things work, right? So the first thing that we'll do is we'll load the meeting bank dataset, and so for the purposes of this presentation, I've created a smaller version of the dataset. Um, it's about 5% of this entire dataset, because the entire data set is approximately 15 million tokens in size. And so for the purposes of this, I have essentially used only 258 items from that data set. So, and you will see that we have about 1 million tokens or so, right? So let's go through this. Um, and if you want to take a quick look at the transcript, this is how a transcript looks like. Right, like an assessment has been called out, bill number has been stated, there's a person called Councilman Lopez, and then they're talking about various different things over here. And if you've seen these kind of council meetings, you would notice that it's a fairly standard format in which they start off with introductions, talking about various different bills. They would go about debating those bills and then finally come out with some action items associated with it, right? Yeah, so we're just calculating a few things here. So as you can see, in terms of the analysis, we have about 258 transcripts, 1 million tokens, and then the average number of tokens per item in this transcript, which these transcripts also could be like broken down into smaller items, is about 3,864, right? And the reason I wanted to do this data analysis is I would also encourage you all to do this before you build any sort of generative AI or machine learning application. It's very important to understand your data set, the different intricacies of it, what you're dealing with before you actually build, any sort of application that deals with this data, right? And that's where tools like AIMon and ApertureDB really help you. So processing all of this large amount of data is not a small, easy task. So you can easily do that using ApertureDB and AIMon. And I'll show you in a bit how all of that is possible. So one other comment here. Um, as you can see, this data set size is so huge. It's actually fairly representative of many different enterprise applications, right? Most enterprise applications have this kind of data, and even if you're building a small niche application in your enterprise, it's very likely that you will run into this kind of a scale of the data, right? And it doesn't necessarily have to be just company internal data. It could be that your application needs external data, which in itself has orders of magnitude in size, right? So one thing I wanted to stress here is it's not as simple as taking this entire data set dump and dumping into an LLM and then asking questions on it, right? Like, I mean, the most simplest thing that I've heard some people talk about is, hey, why can't I take this entire data set dump and put it into ChatGPT and then ask questions on that? Why do I need to like sort of build these niche specific applications, right? Well, one of the reasons is an LLM, has a very limited context window, 128K. There are some LLMs which have about a 1 million token context size, but even those, even when you have a 1 million token context size, it's very important for you to specify the right kind of data that you would send that you need to answer a user's question. Otherwise, typically, when you have a large amount of data, LLMs tend to ignore certain parts of it. Like it may not pay attention to all parts of the data, and then you might end up with low accuracy and low, relevance problems, right? Okay, so in terms of the queries, so I have crafted a few set of queries here. Again, this is a data set that I built, and let's go over them just step by step. As you can see, I'm also executing the notebook as I'm talking through this. So we have like what was the key decision made in the meeting? What was the next steps for the team? Summarize the meeting in about 10 words, right? Like so, there's a set of diverse set of queries that I'm trying to craft here so that I can test the eventual LLM application that I will build through this exercise, right? And this is also something that I would recommend anyone who's building LLM applications to do. Just come up with a set of queries that you want to do. Think about it from this angle of software development, where you have test cases, right? Like you have a piece of code, some functionality, and you wanted to um, look at whether that functionality that you built works. One quick way is to just test it with one example, and that's okay, I guess, when you're developing. But at a certain point, you want to make sure that various different use cases that feature that you're building, um, you need to make sure that it addresses those use cases, right? Yeah, so a few more things over here, like who's responsible for completing tasks, what were the decisions made, what did the team decide about the project timeline. So some specific details that I have incorporated in there. And also, things like, there's a sort of an instruction embedded in this, like you want to make sure that the LLM summarizes, or sorry, your generative AI application summarizes this data, but also makes sure that the summary is within 10 words, right? Okay, so now that we have our data set, we have our set of test cases or our queries. The next step is to figure out what metric do we measure, right? So when you build an LLM application, like let's say in this case, you're building a chatbot or the question answering application on a meeting bank data set, how do you know if it actually works? How do you know if it works well? That's when you start thinking about accuracy, about relevance, and all of those things, right? So I will go ahead and define a formal definition of relevance so that you can use this to improve your applications. So and iterate on them, right? Like so, you would basically build say the flow would be like you would build a first version of the application, use this metric to check how good it is. Then you would do some modifications on it, and then again measure this metric, and hopefully the second iteration is better than the first iteration in terms of the relevance, right? And I'm going to show you that exactly that in this notebook as well. Yeah, so talking about the relevance metric, right? Like so, it will help us understand how good the LLM responses are for the above set of queries. We'll be essentially taking an average of the relevance for each of the queries. And in order to actually measure them, we'll be using a combination of three sub-metrics from AIMon. Now, at the start of this talk, I talked about how AIMon essentially helps you measure various different quality metrics on your LLM applications, right? Things like your relevance of your application, relevance of your RAG, and whatnot. So the three metrics that we'll be using here is the hallucination score, the instruction adherence score, and the retrieval relevance score, right? And I'll talk about each of those. Maybe I'll spend a couple of minutes just talking through this because this is pretty important. And hopefully I can share the intuition behind why I chose these, right? So when we talk about hallucinations are essentially factually incorrect or completely fabricated information. Now, factually incorrect information could be things like, you have a certain fact mentioned in your original data set, something like the version of my project was 3.1, but then the LLM output, the version of the project was 4.5. So that's a factual inaccuracy, right? Um, and a fabrication is something that's completely made up, which is not relevant at all to your source of truth, right? So the hallucination definition here is essentially whether your LLM output is within the semantic bounds of the context, which we treat as the source of truth, right? And it's important in uh, enterprise applications, because you want to make sure that the LLM answers based on the domain which is represented by your context data, as opposed to answering from a general domain. Like for instance, if you talk about SAP, let's say the acronym SAP, right? Like in the general sense, it could mean SAP the company. It could also mean various different things in the plant kingdom, right? But SAP might be an acronym which is very specific to your organization. So um, you want to make sure that the LLM uses that definition of SAP versus the general knowledge, right? So that's why we use the context to ground the LLM. And hallucination essentially is the score is checking how grounded is your final output, right? Instruction adherence is essentially when you have a set of instructions embedded in your prompt, and you check whether the output of the LLM has followed all of those instructions. Um, and just to demonstrate that, right, like you could have an instruction which looks like this, and just to execute that. So ensure that the response answers all parts of the query completely, ensure that the length of the response is under 50 words, and the response must not contain abusive language or toxic content, and then ensure that the response is in a friendly tone. So you can see that a couple of these, like number 4 and number 2, are like business specific requirements, and you can have any sort of these requirements, right? But the other two are pretty obvious, that hey, the LLM should obviously answer everything properly. So AIMon's instruction adherence detector essentially ensures that your LLM response followed all of these instructions, right? And then finally, this is the retrieval relevance score. This measures how relevant a particular document is to a query. So essentially, when you're giving a set of context to your LLM, you want to make sure that that context is very relevant, or it actually has the content that the LLM can use to answer that question. So that's what this retrieval relevance score measures, right? And over here, I define this relevance score as a weighted function, which gives about 35% weight to the hallucination score, 35% weight to the instruction adherence score, and about 30% weight to the retrieval relevance score. So mostly balanced, but I'm slightly you know uh, biased a little bit more towards, I'm leaning a little bit more towards or sort of preferring more towards the hallucination and the instruction adherence score, because for me those are the two most important pieces. And then I also want to balance whether my retrieval was properly measured, right? Yeah, so this function here essentially just does this. There's some boilerplate code here, but we won't get into that. And then this function here essentially runs, sets up AIMon. As you can see, there's some configuration. We configure hallucination scores, the hallucination detector, instruction adherence detector, retrieval relevance detector. There's also something called the task definition, which we'll talk about if we have time. But essentially, what we help you do is we help you tune uh, the retrieval relevance evaluator to your specific task. In this case, it is about whether the context document is relevant to a specific query. And you can say that here the domain is the meeting transcripts, right? So that the AIMon's retrieval relevance grader understands which domain it's trying to operate in. That's the essence of it. Um, Yeah. So essentially, you set up this decorator, which is like a simple Python decorator. Now, before we get into ApertureDB, I will go with a very simple approach. Let's say you don't have a RAG or you know a vector DB that can retrieve the right documents for you. We will instead just use like a simple approach that uses Levenstein distance, a pretty simple algorithm to match the document for all of these queries, right? And then we select the top three queries that will be sent to the LLM, right? So very, very simple brute force approach where I manually match the queries to the documents, and then essentially get a response from the LLM, right? So this particular step I will not execute because it takes about 2 minutes, but you can see, what it does. Essentially, uses a library called Fuzzy Wuzzy, which is an interesting name, and then extracts like the best match documents from that, and then sends the best match to an LLM, which is in this case it is OpenAI, right? You can see from this function here, it's querying OpenAI with those documents. And if you can see that it's decorated with the AIMon detector, which essentially helps you calculate the relevance score, right? So at the end of this, the relevance score over here is 37.2189, using this very simple approach, right? Like which does not use ApertureDB or any of these other approaches. So this helps you sort of get a baseline to understand, how a very very simple brute force approach can perform. So you can see that this is the relevance score. And then if you want to qualitatively measure it, you can also inspect this qualitatively, right? Like, so what was sort of the results of this inference. So over here, for the first query, what was the key decision? You can see that the key decision was to place the bill in 1961. Um, sorry, 161, and then there's some more details. It's quite wordy though here, especially on the second one. If you look at this, what are the next steps? It came up with some next steps, but it's quite wordy, I would say, in this case, right? Um, it did a pretty decent job with this one, I would say. Like it summarized the meeting within 10 words, and whatnot. So yeah, so that's like a quick overview of a very simple approach. And I'm going to get into why ApertureDB and how ApertureDB actually helps this. But before I do that, I want to take a quick pause and just check if there are any questions whatsoever before I proceed. Okay, so no questions, I assume. Um, Perfect. Okay, so let's get into why ApertureDB, right? Actually, let's switch over here, and I'll talk about ApertureDB in just a second. So in the previous cell, that approach that you saw that we took a very simple approach, took Levenstein distance, manually matched the queries to each document, like serially iterated over them, and then sent it to the LM. This architecture is a little bit different. So what we'll do here is we'll basically call the meeting bank dataset, sample the raw documents, and then index that into the vector store, which in this case would be ApertureDB. And then at query time, when a query comes in, the first thing that the LLM application would do is make a vector store query to ApertureDB and then retrieve the relevant documents from ApertureDB, make the LLM inference. There's an LLM inside this. Review the results with AIMon, and then send that response back to the user. So that's a basic overview of this architecture, right? And the reason we chose ApertureDB, so we've all sort of evaluated a few other, vector DB providers, and we really like ApertureDB because mainly for all of these different reasons, right? Like, so the ingestion time performance for ApertureDB is like for a 100K item corpus is about 67 seconds. You can see like it's quite high, much faster compared to the other alternatives. KNN is the nearest neighbor lookup. Basically, when you in this particular piece here, when the LLM tries to look up relevant documents, that's what this row is measuring, and you can see that ApertureDB is quite fast compared to the other options here. We also like the scalability aspect of ApertureDB. It's we've had some amazing support from the team, and then the other two providers, one of them was good, but not as good in terms of the scalability requirements that sort of the enterprise applications, especially the ones we deal with, require. Right, performance-wise, amazingly fast. In fact, we have one of our engineers who quoted saying that this is, really fast. We are pretty happy with the speed of ApertureDB. Cost-wise, yeah, there's a variable cost here associated with Aperture. There's also a free tier available, which you can obviously use. There's like a single, community edition Docker container, which you can basically install and make that work. The In terms of cost, of course, this provider was a little bit lower, but I think in terms of overall trade-offs, given that we wanted faster indexing, faster retrieval, and higher scalability, that's why we ended up choosing ApertureDB for, obviously for this presentation, and also for some of our core applications that we deploy internally, right? Yeah, and again, want to stress that we use the hosted version of ApertureDB. Okay, so a few things here. So we are going to go through some functions here, which essentially allow you to process text. Over here, you can see that we are using LlamaIndex as document. And again, this is uh, going to use ApertureDB's vector store, which has a plugin for LlamaIndex shortly. But this code here so far is just pure LlamaIndex, right? So all we do is we get the documents right over here, and then we process them. There's some pre-processing step, which is just essentially combining all of the documents in there, and then creating this set of this document class from LlamaIndex. We also set up the OpenAI embedding model here, which is in this case using the text embedding 3 small with a batch size of 100. And yeah, there's some retry thing that we add in for making sure that there is some reliability on the API. Over here, we set up the ApertureDB vector store, and you can see that this is a plugin provided by ApertureDB from LlamaIndex. Yeah, so pretty straightforward. Set up the vector store, set up the storage context over here, and then finally you have an index object, which is the vector store index based on these nodes. And again, this nodes was we generate the embeddings for these nodes from the raw documents that were generated here, right? From these documents, you generate embeddings using this function, the embedding generator function, and then we create this vector store index essentially. So far we have built this piece, and I'm going to quickly show you how to build this piece now, right? So now that you have the vector store, the retriever, you would basically set up your system prompt. For the purposes of this exercise, it's quite simple, but in practice it can be quite involved. Your system prompt would be consisting of various different instructions. You would have some chain of thought reasoning. You would also have maybe some sort of examples that you would want to provide and whatnot, right? And again, for the LLM itself, we'll be using OpenAI's GPT-4o Mini with a temperature setting of 0.1. And just a quick note there, the lower the temperature, the less creative the LLM gets, and lesser is the tendency to hallucinate when you use a lower temperature there, right? Okay, so for the purposes of the query engine, as I said, the goal here is to build a query engine that answers questions, these set of 12 questions that we created on top of the meeting bank data sets, right? The LlamaIndex framework has a very cool abstraction called the query engine abstraction. So we'll essentially use that. And you can see we pass in our retriever, our LLM that we just set up, and then build the query engine. Um, and then finally, there is some additional code that we have written to extract sort of the retrieved documents. So basically, when you have these retrieved documents, now that we're using LlamaIndex, all of this is encapsulated into one object, right? Like, so for AIMon to be able to make its judgments, it needs access to the internal relevant documents and whatnot. So that's why we have written this function, which essentially extracts the source documents from LlamaIndex's retrieved values, right? Yeah, so as you can see, there is one single line of code here. This is the ask and validate function, which is a wrapper function that calls LlamaIndex to get a response, extract the raw documents or the context documents that were used to generate that response, and then also call AIMon to judge the relevance of that response, right? So this particular thing is a quick step, just and I'm going to execute that very quickly, just to show you how this basically works. Essentially, all it's doing is it's querying LlamaIndex, right? And it's also querying ApertureDB to get some data back. So you can see for this particular query for Councilman Lopez, it got some data back. This is the actual text that was retrieved, and then it also generated a response for that text, and then if you want to see the raw AIMon response, this is how it looks like in the detect result. You have, the hallucination scores. It gives you a sentence level breakdown of whether it was hallucinated or not. In this case, it was not. There is the instruction adherence detector, which is, if you look at this carefully, it's looking at every single part of the instructions that you had specified and validating whether the output actually followed those instructions or not. So in this case, the score is 1.0 because the output was perfect, right? All of the instructions were followed. And then retrieval relevance is an important one just to look at. So essentially, all of the documents that were retrieved. So in this case, it looks like there were 5 documents that were retrieved. It shares the relevance of each of those documents. So in this case, the last document seems to have the most relevant to Councilman Lopez. So because it looks like there's a discussion where Councilman Lopez briefly talks about funding issues and all of that, compared to some of these other ones, right? So the other ones are also close because all of them clearly mention Councilman Lopez, and our query was quite simple, right? So yeah, so that's how the actual response looks like. Just looking at time here, I'm going to quickly go over this. Yeah, and then finally we run through we run through all of the queries, the 12 different queries that we have here, through the ask and validate function, and compute the relevance score here, right, for each of those queries, and then we aggregate the relevance score here. So you can see that in terms of the relevance score, it is 46.6 compared to the previous relevance score of 37.221, right? So that's about, let's say, um, a 25% increase uh, in relevance, right? So pretty so just to summarize what we did, we basically went through a very simple brute force approach, which did not use you know ApertureDB, and we measured the relevance of that brute force approach using AIMon. And then we used incorporated the ApertureDB technology using LlamaIndex. And then we used AIMon to generate a relevance score for this as well. So this was a second iteration, right? If you remember what I had said earlier, where as you iterate through your apps, you want to make sure that this relevance score is improving. And then very clearly from this, you can see that the relevance score improved from 37 to 46, about a 25% improvement, right? And if you notice the qualitative results over here, it is also much nicer, I feel, right? Like the key decision was made. Yeah, if you inspect all of these things, um, and the reason for that is you're getting far more relevant documents for your queries versus catch-all, which the brute force thing did, right? So yeah, we can declare victory over here, saying that the relevance improved based on iterations. We achieved both of our goals, which again, just to jog your memory over here, was to build, define, and measure the relevance of your application, and then finally build a LLM application that answers a user's query using the meeting bank data set. So we were able to achieve both of that using this notebook, right? One final thing that I will mention here is AIMon also has a UI. So essentially, you can look at this UI to monitor various different things of your application. Over here, you can see that you can get an overview of what were the hallucination scores over time, what was the instruction adherence performance. And if you look at your requests, you can see all of the requests that we made. This was the Councilman Lopez request, which was made just now, right? And you can see very clearly that there was no hallucination associated with this. You can even see instruction adherence was perfect here. This and then we also put this context documents in the UI, so you can see what were the context documents, what was the relevant scores. We provide an explanation why we thought the content over here was relevant or not relevant to your query here, right? Yeah, so this was a very quick overview of how to use ApertureDB and AIMon to first define a measure of relevance and improve relevance of your LLM applications as you iterate through it. Hopefully that was useful, and that is the end of the content that I had to present. So
Thank you so much, Preetam, for giving us a deep dive into improving the relevance with the AIMon and Aperture Data Solution using ApertureDB. We do have one question, and that question is, do the documents also get stored in ApertureDB to retrieve via LlamaIndex? If not, could we store it and make it even faster to retrieve? And this is from Vishaka.
yeah, so do the documents get stored into ApertureDB to retrieve via LlamaIndex? If not, could you store it and make it even faster to retrieve? They do get stored in ApertureDB, from what I can tell from you know, the LlamaIndex plugin that we have, and we do see like the descriptor set, which has the meeting bank data set. So and I didn't show you that step where we index and store all of those documents, but because that would take some time because it needs to generate embeddings. So it would take about 10 minutes or so just to go through this entire data set and generate the embeddings and store into ApertureDB. But Gautam, maybe you can chime in on the LlamaIndex ApertureDB plugin just to confirm what I just mentioned. I assume that once you store it into LlamaIndex's plugin there, it will actually index it into ApertureDB, right?
Yeah, that is correct. It basically takes the document, or shall I say, like the text, like the raw text of the document, and puts it as a property on the embedding, which is like stored as a node. ApertureDB is also a graph-based storage, graph-backed storage, and everything is treated like a property on a node, and then there are edges to depict the relationships between nodes. That being said, in the implementation, in this current implementation of Llama-based LlamaIndex vector store, this is how it actually gets up persisted as.
Another question that we see that we often get is around sort of when to use a vector DB versus an indexed and versus an inverted index. So, Preetam, is it possible you can talk a little bit about that?
Yeah, absolutely. And Gautam, feel free to chime in as well with your thoughts. But essentially, when you want to do some sort of semantic search, when you want to do like you want to have semantic understanding of your data, that's when you would use something like a vector DB. And just to clarify what I mean by that is let's say you have a query which says who is the king, right? Like something as simple as that. But everything related to your documents has things about palaces, about King Arthur or something like that, and maybe something about jewelry and the queen and all of those things. And maybe you don't even have the word king in there in your documents, right? So that's when you know that king is very related to say a palace, or very related to um, jewelry, or even very related to a queen. So at that point, your vector DB can actually retrieve those documents to serve as relevant documents for your query, as opposed to a reverse index, where if you're trying to search for the word king and you didn't find any of that, none of the documents would get retrieved, right? That's one way I like to explain it. But I don't know, Gautam, you have any thoughts on that? Any other
Yeah, I
points?
think that's a very accurate way of describing the differences. It's uh, in a vector world, I think everything is treated as their relative relations rather than the words or the keywords themselves. So and so you needn't even match them exactly like uh, other certain distant metrics like Levishi, like you used in the first example, and I'm assuming that is why you ended up probably getting up more context than you would have actually desired for
Hmm.
that query.
Yeah, exactly.
And our final question deals with can the relevance go even higher? Can we use AIMon to learn tuning context windows and other parameters that are outside of the vector database?
Oh yeah, absolutely. What I showed you was probably 30% of what the capabilities of the AIMon platform is. Just to give you an overview of how to improve relevance there, right? One quick way is to use AIMon's re-ranker, which if you remember the UI that I showed you, where it has the context documents and the relevance scores and whatnot, there's also this explanation associated with it, right? Which has like, why is this document associated with, why is it relevant or not relevant to a particular query? You can go back and tune what I had shown the task definition to make sure that the relevance is more properly captured. Or you can also go back and tune your prompt based on this feedback and ensure that your LLMs are performing better, right? So you can basically take that loop, put it back, and add in a re-ranker, which and we didn't talk about a re-ranker, but essentially it's one more phase of ranking that you do after you retrieve documents from a vector database like ApertureDB, right? And the reason why people use a re-ranker is because it's a more heavier algorithm to specifically match the right pieces of content for your query um, and your content, right? And then there are several other pieces you could use, things like guard railing. You could use things like the improvement data sets that we provide. Yeah, I would highly recommend checking out the documentation. to see how you can use these tools to improve your application.
So, well, thank you both, Preetam.
Can I ask a quick question because
Sure.
Go ahead.
it just popped up when the notebook was being presented, and this is with the reference to this calculation of relevant scores,
Hmm.
and this weightage, and you already told about how you assigned these weightages, and the last parameter uh, had a slightly less number of in terms of the percentage.
Hmm.
I just you wanted to get a sense of the definition of that term. I somehow that's the last term of the average retrieval relevance score. Uh,
Hmm.
what exactly? How would you define it? Like, what is that metric you can say?
Yeah. Yeah, absolutely. Great question. So retrieval relevance is, in the most simplest form, essentially takes a query and a document and then finds out whether the document is relevant to the query. Now, what does that relevant mean, right? So everyone tends to have their own definition of relevance, right?
Right.
And that's where sort of on a per domain basis, you might have like a different definition. But in essence, what it means is, does it have all of the necessary information in the document that is needed to answer that question, right? So that's a measure of, so it's a score between 0 and 1. Closer to 1 means that this document is very relevant to this query. It has all of the information that's needed. Closer to 0, it has very little information that is available for this to answer this query, right? And the way you can use this is rank it, right? Find the documents that have the most highest relevance scores, and then only use them to send it to your LLM to answer your query. And the average relevance, because you will match multiple documents for these queries, is just trying to check if your average relevance score is high enough. Because if you take 100 matches, the average relevance score will be very, very low because you have a lot of unrelevant documents, right?
Right.
But if you take only the most relevant documents, you take, like, say, the top 5, top 10, top 50 sometimes, then you'll know that the average relevance score is actually quite high. And then the LLM does a much better job at answering your question.
I see, but it in no way qualifies basically the quality of the embeddings or the model you've chosen to generate embeddings based on what all could have been. Like, okay, uh,
Yes, yes. The,
that
the
is
quality
another.
of the embeddings will retrieve this model basically checks how relevant a query is to a document. If the embeddings are poor in quality, then it might have matched a document which it thought was very high quality, but then the relevance checker found that it is actually not high in quality, right? Like, so that's
So
where
it would give a
improve.
certain
Yeah.
indication, but
Yes.
okay,
Yes. Absolutely.
understood now. Thank you very much.
Well, thank you once again, Preetam and Gautam, for wonderful lunch and learn about improving RAG relevancy.
Yeah.
We're at a little bit over the top of the hour, but wanted to share one last screen with our attendees. You will get access to all the links. One to sign up for ApertureDB, AIMon, as well as the collab notebook used here for you to go ahead and try this out yourself. And a quick comparison. Also, we also have several blogs that you can also read to learn more about the solution. Once again, I'd like to thank you so much for attending our lunch and learn, and please join our mailing list or sign up for our Aperture Data LinkedIn page, as we have more lunch and learns in the future. And our next one will be about this amazing, exciting feature we're launching called workflows. Thank you, and have an awesome rest of the day.
Bye bye.
Thank you, Denise, and thank you,
You're
Gautam.
welcome.
Yeah, thanks,
Thank you.
everyone
Bye,
else.
Preetam. Bye, Dennis.
Bye bye.
Bye.